We talk about the flood a lot, but there's one thing I don't commonly see presented, and that is kind of an outline of what happened during the flood. What were kind of events? What kind of processes were involved? And so this is a simple description of that, of how we understand what probably happened at the flood. We're given just a little information. In the 600th year of Noah's life, in the second month, on the 17th day of the month, on that day, all the fountains of the great deep burst forth, and the windows of the heaven were opened. The rain fell on the earth 40 days and 40 nights. Well, that kind of gives us a big picture, but let's look a little more closely. And to be able to describe, show what I'm trying to say, we need an illustration. So if we have here an orange, you can cut it in half, and then you can see the inside. So here we have the earth. We need to cut it in the middle so we can see what's inside. You heard a little bit about this from Ronnie the other day. And we can turn it so we really get a clear picture of what's inside, just like we see with this orange. And so that allows us to sort of illustrate what we think happened during the flood. So this cross-section of the earth, we have ocean. Notice the kind of material under the ocean is different from what is under the land. And some features of this we don't really have time to explain, so don't worry about it. But the land, the continents rise above the water. The ocean is in the basins. And then what happens? Then the flood comes and all the animals come in the ark and they launch the journey. So I find people see the flood kind of this way. The water came up and covered the land, and then it went away, and it was all done. Was the flood that simple? Well, absolutely not. It was a very complex event. So how do you cover the land, the continents with water? Well, the ocean floors had to rise and or the continents sink. And then the fountains of the deep break up. Okay, so what was that? We'll talk a little bit about what that might be. So it's a very complex event. You have to, you can't cover the land by lots of rain, because it'll run off and it's just a cycle. You need something much more, like ocean floors rising and or continents sinking. And there are amazing things happening during the flood. You got all this volcanic activity. And there's unbelievable amount of lava. I think you're going to hear about that from somebody else. During the flood, let's see. Then there are, we know about earthquakes, and we see earthquakes on a small scale. Here's a ditch up near San Francisco, and you see this problem right here. There's a fault moved right there. And here's a nice orchard of fruit trees in Southern California. You see something is funny right here. Okay, there's a fault right through there. It's moved. Okay, so we see these things on a small scale. Here we see a hillside in Arizona. Notice these layers. You can see, well, this one ends. What happens here? There's a line, there's a fault right through, much bigger fault. And I think this one isn't the matching this one. I think this part went down here, and you don't even see it. So there were earthquakes on an enormous scale during the flood. And they caused things like this. These layers were laid down horizontally, but not on top of the mountain. They're laid down in the valley somewhere. And now they're up here at the top of the mountain, with marine fossils up here because they've been lifted up. Or you have rocks that have been tilted at a right angle, and I think we're going to see some of those maybe, if I understand right. And so whole mountains have moved, and we understand the mountains before the flood were gone. New mountains formed during the flood and after the flood. Now, here are the movement of these continents. Is that real? Well, there's actually a lot of evidence to say, yes, that's real. Those movements really have happened. And let me suggest to you that that's kind of the big event happening during the flood. So maybe even when these things split and start moving, that's what starts the flood. And we read in the Bible about the fountains of the deep. Well, if the land starts to split and separate, hot magma is going to come up. It's going to start heating the ocean water and boiling it, and probably be huge jets of water and steam and rocks rising high in the air. And one theory, which is probably pretty reasonable, is that this tremendous upburst of water and steam is what brought on the 40 days of rain. You're not going to have 40 days of rain to cover the land just by evaporating water. It takes something much more. And I would just suggest to you that this plate tectonics process is really the main big event during the flood. Okay, and all of this, animals get knocked off. They get killed and they get buried, and that's where all these fossils come from. And like was implied earlier, I think there would be a very meager fossil record if it were not for the flood. So, and all of this then leaves this sequence of rock layers that we see. And then you have, after the flood, you have tremendous erosion that changes the whole landscape. Okay, so the flood, you have all these dramatic processes happening. Noah's up here in his boat. Was that a fun ride? Well, no, I don't think so. It's going up and down. The lions are roaring, and the monkeys are screaming, and the ravens are complaining. And I feel sorry for Noah. But anyway, it was a rough ride, as implied here. Okay, from flood to post-flood. Now, where are you going to get rid of all that water? Is it going to evaporate? Well, what happens when water evaporates? It comes down as rain. So that cannot be what happened to the water after the flood. You have to have much larger scale things happening. You have to have continents again rising up, ocean floors sinking down. And we mentioned John Baumgartner's catastrophic plate tectonics. That implies that continents were sinking down into the mantle of the earth, and there's actually physical evidence for that. And that may seem really wild. We don't even know where the continents were before the flood. One thing to keep in mind, the ocean floor material is young. We got this geologic column, Cambrian to Pleistocene. Okay, the ocean floors that we have now do not date more than about half the way down. So that tells us ocean floors mostly were formed during the flood. They are different from what was here before. So things have really changed. There have been radical processes going on. And I'll just mention one thing that also may sound wild to you, but think about this. If you had a flood happen right now, like a global flood, where would you expect the fossils to end up? On the continents or in the ocean basins? Especially the marine fossils. Would you expect them to end up on the continents or in the ocean basins? Okay, the fossils we have are almost entirely on the continents, not in the oceans. Something wild happened. It looks like what our continents now were actually ocean basins before. So that's why, I'll come back to that point in a minute. So you have these tremendous processes happening. By the time the flood is done, it's like this or close to that. And so here we have a comparison, compare pre-flood and post-flood. Okay, notice here are the continents, here's the ocean. It's not that way afterwards. Something radical changed. And I don't know that I can explain all of that. The details here are one hypothesis, which I won't even get into. But what used to be ocean floors are now continents. Now, okay, so the Bible tells us, and it tells us in the last days scoffers will come, saying, where is the promise of his coming? For ever since our ancestors died, all things continue as they were from the beginning of creation. They deliberately ignore this fact, that by the word of God, heavens existed long ago, and an earth was formed out of water, by means of water, through which the world of that time was deluged with water and perished. So, Peter is predicting the last days, people will deliberately forget the creation and the flood. Is that true? Well, absolutely. That the scientific world is ignoring that. The earth as created was very different from the earth as it is now. It used to be a delightful place everywhere, certainly. Now there are places where the water is not well distributed. There are many places where there just isn't much water. Other places are beautiful. So the earth has radically changed. And again, we come back to plate tectonics. And it's the theory is that we started here and then it has moved gradually more and more apart. And you've already seen a presentation of this. There's a lot of evidence to support this. I live on the ring of fire, the circle around the Pacific Ocean where there's more earthquakes and volcanoes, and we feel those shaking there in Loma Linda at times. So there's a lot of evidence for this process, which I would suggest again is basically the major thing that happened during the flood. Okay, unimaginable amounts of sediment were deposited in layers. These layers in the Grand Canyon, and this is above the Grand Canyon, above the Paleozoic. These are extensive layers. Each of these layers go over thousands of square miles, thousands of square kilometers. So enormous amounts of sediments, and we don't fully understand the process, how they got from where they were to where they are now. We've never seen a global flood, and so how do we answer some of these questions? There is equally awesome erosion. Here you see a whole, this tremendous area has been folded up like this, and you see these canyons. Tremendous amount of erosion, and it's fascinating to study those. I would suggest that most of this erosion happened quickly after the flood, and not much has happened since. And so, here's more. The Monument Valley, these monuments, why are they there? Because these layers used to cover the entire area. And a whole lot more of it used to cover the entire area, but it's been taken away by processes immediately after the flood and later. The pre-flood mountains have disappeared. That's been suggested to us in some of our literature. New mountains formed, and indeed these mountains have formed in they're late in the geologic record. Somebody mentioned yesterday the mountain ranges are all basically in the upper third. And so the mountains have formed afterward. And marine animals, fossils on mountaintops, not because the flood covered this high, but because these have all raised up, way up, after the flood. Okay, let's just briefly go through a little more information on this question of why animals are arranged in what looks like an evolutionary sequence. And this is an attempt to illustrate how this would happen. And I'll use this diagram. This is a drawing of what perhaps the pre-flood Earth would look like. You got oceans and going up to the high elevations. On this side, we'll show what happens to things. Things get killed. They get deposited in the rock record in layers of rocks over here. Come back to this briefly in a little bit. So the suggestion in this idea of ecological zonation, this begins an explanation. I'm not going to give you the whole explanation. We've never seen a global flood. How could we know how this really works? Well, we can at least begin to think about it. So the flood begins and it destroys this lower habitat. Takes all those creatures and puts them over here in the lowest Paleozoic rock layers. Okay, so this habitat is gone. Pre-flood habitat has been destroyed. Now the next part begins to be affected, and those animals are brought over here and buried in the rocks. And so this continues, one layer after another. Now this layer is getting destroyed. Now you start to get more of these more terrestrial creatures. Over here, let me just make a comment here. Down here, there are no people. There are no horses. Why? Well, the one thing we can say, that's a big question we don't know how to answer, but one thing we can say is there were people obviously living at this point, and other animals. They must have been in an area not where fossils were not forming. Today, fossils are not forming everywhere by any means. You have to have just the right kind of environment for fossils to have a chance to be formed. These animals, these things were not living in places where that was happening. But where things were being carried, again, you get the next habitat, gets brought in here, and all these creatures here, the dinosaurs, they get buried and destroyed, and then that habitat is gone. The evidence of it is gone. It's over here. And finally you get up to the point where you might be starting now to have new habitats filled after the flood, and you start burying those animals. And certainly by up here, you're now burying animals that were living after the flood. So, just a summary then, you destroy one habitat after another and bury them then in a sequence in the rock layers. And the first part of the flood, are you likely to bury monkeys? Well, no, they're not living here in the ocean. You won't get them until you get up here. And so this seems to answer at least some questions about why are these things in this order. Does it answer all the questions? Well, we'll come back to that. Here. Okay, so we have this sequence of things. Again, does this answer all the questions? Well, certainly not. What it is a, this thing tries to put something in here. Okay. It's a beginning. So this is a beginning of our understanding. We can understand at least this much. There have to be many other important factors also influencing when an animal becomes a fossil. And Ronnie just mentioned one of those. As new sediments come in, it brings in new creatures. Just mention one other set of ideas. When in the flood does an animal first get buried, die and get buried? And so there are several factors that would influence that. Ecology. You got creatures living here by the ocean or in the ocean. You got others living up here in the mountains. Which of those is more likely to get buried first? Well, certainly the ones living here and not those here. So ecology will affect it. Behavior can affect it. If a catastrophe comes, which is more likely to react appropriately and survive? This one or this one? Take fish. A lot of fish, if there's something happens, something unusual, catastrophic happens, what's the fish likely to do? Well, many of them will dive down into the bottom, in the mud, where they're normally safe. Is that going to help them in a catastrophe? No, it's going to be the wrong thing to do. Okay, so behavioral flexibility and intelligence will have a great effect on who is more likely to survive longer. The next one is related to that. Mobility, who can move around and escape a problem easier, this one or this one? Well, obviously some animals are much more mobile and could survive longer. Is that going to solve the whole problem? Well, no, not at all. But it's one factor that would help. So understanding the flood helps us understand geological history. Why are there so many layers of sedimentary rocks? Well, we think the flood describes why are there so many layers, and there's a whole lot more we could say about that. Why are there so many wonderful fossils? And I think a lot of science would have a problem with this, but I think we would not have much of a fossil record if it were not for the flood. Actually, there's an interesting difference. The Pleistocene, the very top, divide that away from all the rest of the geologic record. Below the Pleistocene, the fossils that we find are deposited in water-deposited sediment. Pleistocene, no, that is, you don't find that. The fossils in the Pleistocene and what's happening now are only in very rare, unusual situations like in caves or falling into cracks and that sort of thing. So there's a very great difference in different parts of the geologic record. How did the mountains form? Well, if you have continental drift, which is believed to be, plate tectonics believed to be what brings mountains up, that must have been happening very fast during the flood. How did this all happen so fast? I'm not going to give you a complete answer for that at all because, like I say, we've never seen a global flood. But we can find evidences, which we don't have time to present right now, that say a lot of this must have happened very fast, even though we don't fully understand how. It must have happened very fast and catastrophic. And there are a whole other series of talks we could give on that. What new hypotheses can we suggest for testing? Well, those of us who've been doing research in geology for some decades, looking at it from a biblical point of view, we find that if we come with that worldview, we see things that other people have not seen. Now, why have they not seen it? I read a lot in the anti-creationist literature, and it's clear that people who write that material have no idea how an educated creationist thinks. They know their worldview, they know how they explain things, they have no idea what we're doing, what we're thinking, how we're doing this. And we have an advantage that other scientists do not understand. And they would think I'm nuts, but I'm not. Those of us who understand the Bible, who understand the biblical worldview, if we're going to do research, we have to know everything that they know. We have to understand their worldview, why they explain things the way they do, and how they explain it. We also know our worldview and how we think. We have the opportunity which they don't have because they just don't. We can compare those two worldviews. My friends and I who do this work, we're all the time comparing these points of view and looking for places where we can test. How can we find out what's really going on? When we do that, that's why we notice things and ask questions that others are not asking or are not noticing. And so that gives an advantage, and we can make progress in understanding, even though we will not have all the evidence until Jesus comes. So the Genesis global flood, it was a very real, literal event, I would suggest, completely changed our earth in radical ways that I've tried to introduce briefly. There's abundant evidence for this, can be found in the rocks. It offers many opportunities for serious, publishable geologic research, and we do publish this work. It provides a basis for better answers for many geological questions, and it was a rough ride. And we do not have all the answers. We are not there, but it's exciting to work on it and make progress, and we can gradually make progress. We find more answers when we look. Thank you.